everybody. Today we're going to take a look at properties of logs. Now, there's three main properties. We're going to prove all of them. And the first one is called the product property. So, given its name, it has to do with multiplication. So, let's start. We're going to let x equal log base b of u, and we're going to let y equal log base b of v. Now, given the definition of a log, this means that b to the x equals u and b to the y equals v, just given the definition of a log. Okay? So now, if I would like to multiply these together, if I want to multiply u times v, well, that's the same as b to the x times b to the y. And by exponent rules, u times v is b to the x plus y, right? Given that they both have the same base b, we add those exponents. Now, I'm going to take this and rewrite it in log form. So that is log base b of u times v equals x plus y. Okay, that's definition of a log. And then I'm going to take this x here and this y right here and replace it with what I started with, and that's going to give me the product property. Log base b of u times v equals log base b of u plus log base b of v. Okay, so there is my product property. If I have two logs being added together and they have the same base, then I can condense them down to make one log using multiplication. Okay, so let's take a look at the quotient property. It's going to be almost the same thing. Okay, so here's the quotient property. So we'll start with the same thing. We're going to let x equal log base b of u and y equal log base b of v. So, by definition, u equals b to the x and v equals b to the y. Okay? Now, since this is the quotient property, I'm going to divide them. So, u divided by v equals b to the x divided by b to the y. Okay? And then by properties of exponents, that's b to the x minus y. Okay? So if I rewrite that in log form, I get log base b of u over v equals x minus y. Right? And then if I replace with what I have up here, I have my quotient property, which is log base b of u over v equals log base b of u minus log base b of v. Okay? So if you have two logs that are being subtracted here, and they have the same base, you can condense them down using division. Okay? All right, one last property. We have the power property. Okay, so we're going to let x equal log base b of u. So by definition, that means that b to the x equals u. Okay, so now what I'm going to do is I'm going to introduce a new exponent. Okay, so I'm going to take b to the x and u, and I'm just going to raise both sides to the n power, okay, because I'm just going to do the same thing to both sides so it doesn't change the value of the expression, it's just going to change the way that it looks. So I'm going to raise both sides to the n power. Now, if I have b to the x to the n, you should agree that that's b to the xn, right, given exponent rules. Now I'm going to rewrite this in log form, so I'm going to get log base b of u to the n equals xn. Okay, but now x up here is log base b of u, so I'm going to replace this x with log base b of u, and now I have my power property, which says log base b of u to the n equals n log base b of u, which basically means you can sort of take this exponent n and put it in front and create a coefficient. So let's take a look at some examples here. All right, so let's say I have log base 2 of 6 plus 2 log base 2 of 2 minus log base 2 of 3. Now, if I asked you to evaluate this, you would say, well, that's kind of complicated because I don't know log base 2 of 6 and I don't know log base 2 of 3. But you're noticing that they all have the same base 2, so we're going to use our log properties. Okay? So the first property we'll use, let's use the power property here. So we'll get log base 2 of 6 plus log base 2 of 2 squared, right? So this 2 became the exponent here, minus log base 2 of 3. Okay? Now remember that according to our properties, when logs are being added together, we use multiplication, and then when they're being subtracted, we use division. So this is going to become log base 2 of 6 times 4 over 3. Because here's the plus sign, so that became multiplication. Here's the minus sign, so that became division. So this equals log base 2 of 24 divided by 3, which is 8. And if I evaluate that, I get 3. So this entire expression up here using my log properties equals 3. Okay? Let's take a look at one where we have to expand. Log of 3 root x over y squared. And the directions here are going to be expand to multiple logs. Okay? So I don't like the fact that there's a square root there. I would rather have that be an exponent, so I'm just going to first change x to be raised to the 1/2 over y squared. Okay? Now I have 3 terms here. I have 3, I have x to the 1/2, and I have y squared. So when I separate these, I'm going to have 3 logs. Okay? 3 and x to the 1/2 are being multiplied, so I'm going to add those, and y squared is being divided, so I'm going to subtract. And then my last step is going to be to move these exponents using the power property. So my final answer will look like this. Okay? All right, let's take a look at one more advantage of these properties. We're going to take a look at the change of base formula. Now, the change of base formula is really helpful for when I need to use my calculator. If you notice on your calculator, there's 2 buttons that have to do with logs. The first button obviously just says log, and in the calculator, that's the common log, so that's log base 10. So when there's no number, or there's no base written, that's base 10. And the other button on the calculator is ln. Now, ln is a very special type of log. It's log base e. So because e is so commonly used in a lot of exponential applications, we have log base e, which is rewritten as ln, meaning the natural log. Okay? Now, the calculator doesn't really do logs that are complicated in its head. Somebody just sort of did all of the logs out, all of the different bases with all of the different numbers, and sort of created a table, and the calculator just knows all of those numbers. Okay? So, if I asked you to evaluate log base 2 of 11, you'd say, well, how would I do that? Let's think. Log base 2 of 1/2 is -1. Log base 2 of 1 is 0. Log base 2 of 2 is 1. Log base 2 of 4 is 2. Log base 2 of 8 is 3. Log base 2 of 16 is 4. So you know that your answer is going to be somewhere between 3 and 4. Maybe closer to 3 a little bit, but you're not really sure. So what we're going to do is we're going to say, well, I'd like the use of my calculator. I'd like my calculator to be able to do this. But the issue is that your calculator only knows log base 10 or log base e. So you ask yourself, okay, this by definition means 2 to the what power equals 11. That's what you're asking yourself when you evaluate a log. 2 to the what power equals 11. So you say, okay, well, I would really like to use my calculator. So let's just use log base 10 for now, and then we'll talk about ln. So in this case, you say, okay, well, I would like to change the base. So instead of having log base 2, I want log base 10. So I'm just going to take the log base 10 of both sides. Now remember, you can do this because you're doing the same thing to both sides. Then using the power property, this x goes in front, so I get x log 2 equals log 11. And if I want to get x alone, I get x equals log 11 over log 2. Now, if I just type that into my calculator, I'm going to get the decimal approximation of that exponent. And I'm done. That's change of base. I just changed this log base 2 of 11 to something in base 10. Now, the other cool thing is that let's say you didn't want to use log base 10, you wanted to use ln. Well, you could just take the same steps and you would get ln of 11 over ln 2. And if you type that into your calculator, you'll get the same exact answer as you did when you used a log base 10. Okay? Now, the cool part about this too is that these can move very quickly. You don't have to take all of these steps if you don't want to. So if I said, what's log base 3 of 21? Well, if you look back in the first example, it's really just log of 21 over log of 3. Or you can use ln, and you'll still get the same exact answer. Okay, so that's very helpful for when you are solving exponential equations as well as solving log equations as well as changing your base. Okay, so good luck everybody.